Tribonacci sequence, you're trying to get its Fibonacci sequence, except instead of adding the prior two numbers, you're adding the prior three numbers. This is a good practice with something that I'm unfamiliar with, which is memoization. I did do some research beforehand, but we'll say n memo equals that. We'll say if n is less than or equal to, if n is in memo, then we're just going to say return memo n. Otherwise, if we do the base cases, which is if n equals 0, then return zero equals 0. We just say, and then if n is less than or equal to 2, if memo n equals 1, return memo n. I guess we could just say return 1. We don't really need to say return yet. And otherwise, you just say return trib recursion n minus 1. Actually, do we want to go backwards? Yeah. Memo plus trib recursion n minus 2 plus trib recursion n minus 1. And then we're just going to say return trib recursion n, and we'll give it an empty dictionary. Does that work? Awesome. Time limit exceeded, really? Why? Oh, wait. We need to actually make use of the memo. Memo n equals this, and then return memo n. And that'll work way faster. I wasn't actually making use of the memoization. So to recap, basically what you're doing, this is dynamic programming, but instead of building bottom up, we're building top down. The one that I'm used to is you solve a big problem by solving all the little problems, and then you can solve the bigger problems by basically building that up. This is, even though it's a Fibonacci sequence, which you inherently think would be a result of building up the smaller numbers, it actually is going to go a little bit faster if you build it from the top down. And the way we do that is basically just, let's see, recursively calling the function, and then we store all of the results that we don't have yet. And then we can just, at the top, if we've already seen this before, we don't need to recalculate it all again. And then we can just say, run that recursion with the whole thing. There we go.